Hello everyone. In this video, we are going to build a machine learning system that can predict a person as a diabetes or not. So we are two team members. That is itself me, Appalnadu Saketi, and my teammate Venkateswara Bondalpati. So we will be using one of the important machine learning algorithm, that is support vector machine learning. So we will do our coding in Python. And first of all, try to understand about this problem statement. Then let's try to understand about this SVM algorithm. Then let's get into our coding part. So now we first of all let me explain you that about support vector machine learning model. So in this case, this is one of the important machine learning algorithm from supervised learning algorithm. So in supervised learning algorithm, we feed data to our machine learning model, and the machine learning model learns from the data and its respective labels. So here the labels are most important things. So what happens is, in this case, we train our model with several medical information, such as the blood glucose level and insulin level of patients, along with whether that person has a diabetes or not. So this acts as a labels whether that the person is a diabetic or non-diabetic. So this will be the label for this case. So once we feed the data to our support vector machine learning model, what happens is it try to plot the data in a graph, and once the plot the data, try to find hyperplane. So in this image you can see a hyperplane. So what happens is that this hyperplane separates these two data. So once we feed our new data to this model, so it try to plot that particular data in either of these two graphs, and by this it can predict whether the person has a diabetic or non-diabetic. Now let's try to understand the workflow for this project. So first of all, we need this diabetes data. So we will train our model with the data and respective labels. Then we need to train and trust our data. Before that, we need to pre-process the data by data cleaning and finding missing values and everything. After once completing our data pre-processing, we need to feed our pre-processing data to our support vector machine learning classifier. Then we go for our new data to test our trained machine learning vector machine learning classifier. So now let's get into our coding part. So I will explain about our coding part. That is, first of all, we need to import all the dependencies like numpy, pandas, and train test split and svm, that is support vector mission from skyline, and accuracy score to evaluate our scores. Then we need to then we need to data collection and analysis, to loading the diabetes data set to pandas from data frame and printing the first 5 rows of data set. Then we will do number of rows and columns in our data set. Then we will getting the statistical measures of our data. Then separating the data and labels. Then we will do split our data into x-axis and y-axis. Then we are going to training our support vector machine learning classifier like this is. So then we are going to find our accuracy on the training data set and accuracy on the test data. Then we will get the data accuracy in testing and accuracy in training data. So now let's see, this is what happened. If the person has a label 0, then it is non-diabetic. If the person has a label 1, the person is a diabetic. Now my teammate Venkatesh will continue.
Yes, these are the three files developed by creating a web pages. Well, we have already developed a machine learning model to predict your database using the machine learning model, that is support vector machine learning. Now, what we have to do this, we need to deploy the model into the internet, create a web app by using the Python Streamlight library. This web page will be giving a result, whether a person has diabetes or not by using the. Yes, I entered the random values. The person will medical information to predict the diabetic, whether the person is diabetic or not. Yeah, I'm entering his age. Now once check this is the person is the diabetic. So this is the result I executed. Thank you.